we will wrap up this workshop with a short discussion on how outliers can negatively impact the coefficients estimated by your linear regression. Let us go to this magnificent resource by the University of Brown. And here we can see, I'm just going to start by visualizing a normal data set, like the ones we've been using throughout the intro and this workshop. And we see that these data points here depicted in pink, we see little squares associated with it. The reason behind these pink squares is that if you remember, ordinary least squares for regression uses the square of the residual, and the square of the residual can visually be depicted as the square. So just draw the usual residual, which is the distance from the true value to the regression line. That would be the residual. If you square it, then you add this perpendicular and you get this is the value of the square of the residual that contributes to the loss. However, this yellow regression line is something that we could have guessed. It looks really nice. It's the line that best fits the points. There's no outliers here. Now I'm just going to quickly switch data sets to this one over here, number 3, where here we see that clearly all of these pink points here lie in a very straight line, and we would actually wish the regression line to perfectly fit those points. But there is this one data point here, this one outlier that's skewing completely the results of our analysis. That's because, remember, ordinary least squares is using the square of the residual, and it's trying to minimize the square of the residuals. And remember from our discussion on error metrics that because mean square error penalizes outliers more than other error metrics like the mean absolute error, this particular outlier contributes this massive loss as represented by the square, so much so that it completely skews the results of our regression line, and we obtain this that while it does minimize the square of the residuals, we know that it's just being skewed by this one outlier. So if you were to get rid of this outlier by doing some preliminary data analysis, obviously you don't want to modify its value, you would want to potentially remove it, but we can achieve the regression line that we're hoping for.